Ahora sí, lamentamos los problemas técnicos que experimentamos. Buenos días, buenas tardes a todos. Muchas gracias por acompañarnos el día de hoy. Tenemos el honor y gracias a la colaboración de una de nuestras investigadoras del Departamento de Fisiología, que es la doctora Li Meixian, tuvo a bien considerar mencionarnos que existía la posibilidad de que nos pudiera impartir una plática el día de hoy el doctor Yaden, del cual me voy a permitir dar una muy breve introducción de su currículum para posteriormente pasar a una de las ponencias que yo creo que bastante interesantes que vamos a tener dentro del ciclo de seminarios, que tiene que ver precisamente con publicaciones científicas. Dr. Lieden, thank you to be with us today. We are honored, we are glad for the Department of Physiology, for our chief, Dr. Julieta Garduño, and the research coordination. We thank you so much that you could to give this lecture today. Dr. Lieden is chief of the section on molecular neuroscience in the National Institute on Mental Health in intramural research program in the National Institute of Health in Bethesda, Maryland. And actually he received his Bachelor of Arts in Chemistry in the Northwestern University in Evanston, Illinois. And after he got his PhD in pharmacology from the University in Kansas, in Lawrence, Kansas. He has a lot of publications, and his main research field is on neuropeptide. And he's Dr. Aiden and his research group has identified the neurogenic CAMP sensors responsible for GPCR, GS, CAMP mediated activation of ERK, a major cognitive kinase underlying diverse cellular and circuit functions with the central nervous system. And Dr. Aiden is past president of the International Regulatory Peptide Society and the Catecholamine Society. He's on the editorial boards of Frontiers in Neuroendocrine Sciences and Sciences STKA. Is a senior editor at Journal of Neuroendocrinology and has served on the editorial boards of Journal of Biological Chemistry, Journal Neurochemistry, Peptide, Journal of Molecular Neuroscience, and Science Signaling. And I could talk a lot about Dr. Lieden, but I would like to invite him in front to give us this lecture. Thank you so much to be with us today.
Ricardo, muchísimas gracias for the very kind introduction. Buenos días, buenas tardes to everyone in the audience and those who are with us remotely. And I want to say that unfortunately, no hablo español, or at least not sufficient español to converse and sound remotely like an expert. So I rely on my several colleagues and excellent translators in the audience. If anyone simply wishes to express themselves in Espanol, please do so, and your remarks will be translated to me in case I don't catch them. Because, and I mention that because one other disclaimer. In talking about scientific publishing in 2022 and the decade to come, I feel as an imposter, as I think any of you would. Things are changing so fast. It's comic to think that any of us are experts. So I only stand before you as somebody who's thought about it a bit and who has a great curiosity, having spent decades publishing in science. I have a great curiosity about the coming decade. And those of you who are students, I think, must have some weird combination of anticipation and dread, because change is always difficult. I assure you, you are, for better or for worse, if you're just starting your career in science, you're coming into a decade that's going to change more rapidly with respect to scientific publication than the decades, I don't say since the printing press, but very rapidly compared to the previous decades. So what I would like to do my ambition for our conversation, our colloquy today, is just to ask you to put yourself into the eyes, alternatively, of someone who is publishing, and then as an editor, someone who is receiving publications. And a very important point I want to make is that this is a relationship of twins. The relationship between editors, editorial boards, reviewers, and those submitting papers is an absolutely, it's a very tight bond. And the success of science depends on that bond. And yet there are parts of that bond that are often hidden from us. Process of publishing is not entirely transparent. And one of the goals, I think, for the future is to try to make the process more transparent, but also to make the process fair. And it's not as easy as one might think. So why is it important for everyone to be paying attention to publication? There is a way of looking at it where the talk we're going to have today could be seen as a complete waste of time. And it goes something like this. I'm a scientist. I work in the laboratory or in the clinic. I know I'm doing important work because I wouldn't be in the business if I didn't think I was doing important work. I'm going to do that important work. And when the pieces fall into place and I have something to tell other people, I'm going to pick a journal. I'm going to publish there. My colleagues will help me a bit. What's this obsession with finding just the right journal and just the right place to publish? I feel that having had that attitude as a student coming into the field, what I cared about was learning pharmacology and neuroscience. And I really felt the publication will take care of itself. But I think it is interesting just to take a few minutes to look at it from the point of view of publication. You've all heard the expression, publish or perish. If you don't publish, you won't have a job and you won't do science. There's another way to look at it, and that is publish and prosper. Where you publish is important because you should know who you want to talk to in your field. When you go to a meeting, you talk to an audience. I feel that as I'm standing here and talking with you, that you would like to hear what I have to say. So thanks to the good offices of the professors, thank you, Limay and Ricardo. I know I'm welcome because you welcomed me. But when we finish doing our research and we're ready to publish it, we don't know for certain that what we have to say is so welcome to the scientific community. And it's not that one does research to please others, but I think doing research is a bit like any other human enterprise. When you speak with somebody who please themselves, to please their audience, and in service to their craft. Any excellent pianist wishes to push the border of musicality a bit further. And so we all work to make ourselves happy, but we also want to make sure that we're communicating to other scientists, and in science in particular. You could imagine a pianist doesn't necessarily have to be familiar with the styles of other pianists, although in fact they usually are. But of course, a scientist has to be aware of all the work that's going on around them, or their work would be disconnected, redundant, and ultimately useless. Could be that the controls, I'll just use this one.
Yeah.
Yeah.
With this one.
Perfect. Thanks. So what I'd like to, again, remind you, science publishing is an evolving landscape. And it's evolving so rapidly that many of us are asking, will this evolution affirm the scientific enterprise, or will it undermine the scientific enterprise? There are those that feel that when we publish our work, we aren't really taking advantage of the technology of the 21st century, that we're still going through the paces. As somebody put it, yeah, we use PDFs now, but that's about the only thing that's changed. Okay, is that true? Are we not taking advantage of our abilities to communicate with each other in a way that maintains scientific standards and yet gets information out that we all can share? So I want to talk about the process of publishing one's own scientific results, and then who the participants in the peer review process are. And then I'd like all of us together to ask, how can we affect the future? Can we affect the future? And again, there's 2 points of view on this. One is, it's a laissez-faire system that evolved into a free market system, and other people will take care of it. I'm going to concentrate on doing good science and let the rest of it take care of itself. I really do believe we've reached a point where all of us have to have to own the scientific process, to own the publishing process, and to communicate with each other in a fuller and wider way. So I think there's real opportunities for that in the future. So that's my plug for spending the next perfectly good hour that you could be doing something else. So the process, choosing a venue for scientific publication and how editors and colleagues can help. My own personal editorial experience, Ricardo mentioned, I've been on various editorial boards over the last 40 years, at the Journal of Biological Chemistry, at Science Signaling, Peptides, Journal of Neurochemistry, Journal of Neuroendocrinology, Journal of Molecular Neuroscience. Some of these journals maybe you've never heard of. I only mention them here because maybe you've heard of some of them. And all those journals actually have different styles. And it's interesting to compare their styles. And that helps to make the point that the no-brainer is you publish in the highest impact journal you can publish in. But there are more subtle considerations that are worth taking into account. Who do you want to know about your work? You may prefer to publish in a society journal if you're part of that society and you want all of your colleagues to read it, particularly as they're in a vast sea of information. And they can just as easily Google your paper in the Journal of Neuroendocrinology as in Science. So of course, there's more prestige in publishing in a higher impact journal. But it's not just about prestige, it's also about communicating with your colleagues, forming new collaborations, sharing your ideas. So it's not a simple choice, and it's one that's worth thinking about, because the motivations for publication are, first and foremost, the transfer of information to the scientific community. Well, we are a community of communities. I know as a neuroscientist, it's only been in the last, I would say, 6 or 7 years that I've become, again, thanks to Dr. Zhang's group and her colleagues, I've become more conversant with a part of neurochemistry, neuroscience called electrophysiology. I'm not part of the electrophysiology community, but I'm part of the neuroscience community, part of the cell signaling community. So there's overlapping communities. And so you want to transfer information in such a way that people will pay attention to it. Obviously, also, one is motivated to publish for career advancement and prestige. Now more than ever, I would just put it this way. If you are the dean of a medical school or the chair of a department, your responsibility to evaluate the output of your colleagues is greater and more daunting than ever. You can never take the easy way out. and say, I will reward everyone who publishes in journals with an impact factor greater than 9. And I will punish everybody who publishes in journals with an impact factor under 3. There, I don't have to think anymore. As those of you who are scientific leaders and department chairs and all the other ranks that you hold, you know that it's your job to maximize the potential of the people you work with. You're not like the owner of a soccer team or a baseball team that can just throw out a $20 million salary and get the very best goalie or kicker you want. You work with the people that are surrounding you, and you want their careers to advance. You want them to have prestige. And this goes into your advice that you give people about where they should publish. And finally, a motivation for publication is accountability. This is a group motivation. We don't want it to be difficult for us to publish our work. I can brag about this because it happened in the past, and I was not the first author on the paper, but once we submitted the paper to the Journal of Biological Chemistry, and all the stars were aligned, and we got back 3 reviews that said accept without revision. That just never happens. That's the exception that proves the rule. But we want that. We want the difficulty of peer review so that everyone else has accountability. Of course, I know I have integrity. Of course, I know my work is excellent. Of course, I know how important my work is. But what about yours and yours? Well, I'm not so sure. So it's a good thing there's peer review to make sure that when I read your work in a journal, it's past a certain bar so that I can count on it in designing my own experiments. Otherwise, we're in a solipsistic morass. We have to reinvent the wheel every time because we don't believe what we're reading in the literature. That would be a very bad thing. So I mentioned impact factor a bit dismissively and saying it's not the only thing, but it's a thing. It's an important thing. Impact factor is a very simple number, okay? The impact factor is calculated by dividing the number of times the articles are cited in the last 2 years in a journal by the total number of publications in that journal during that 2-year period. So if you publish in journal X, and it has an impact factor of 5, and your paper gets cited 10 times during that 2-year period, you should look for a better journal. Looks like your journal is not quite punching up to your weight. So it's a very matter-of-fact way to gauge your own. Are you pulling the journal up, or is the journal pulling you up? You know, it's chess players commonly say they improve by playing somebody who's better than them, and we improve by trying to publish our work in journals that are more and more rigorous. And that's just one rule of thumb. So impact factor is important. On the other hand, it's just math. How much does it really matter? And there are certain rules of thumb. We all know what they are. There's a kind of a floor and there's kind of a ceiling. But this simple mathematical formula doesn't necessarily capture the true impact that your work is going to have. And there are other ways of assessing the merit of a journal, and we'll talk about those briefly in a moment or two. But impact factor is an important shorthand. So this is just a list of impact factors deliberately chosen from some time ago, and in this particular clinical cancer journal, a typical article is going to be cited on average 70 times. That's a huge amount over a 2-year period. Sometimes articles impact factor, remember, depends on how many articles are published. So you could, for example, start a journal and call it, the Journal of Quiet News, and decide that
you're only going to publish one article and you're only going to put out one issue per year. So your impact factor is going to be the citations over 2 years divided by 1. Okay, that's going to make a nice big number, relatively speaking. Or you could publish in a journal that like Science magazine or Nature that is published weekly. Well, now you've got to, you're going to have whatever 10 articles a week or 20 articles a week times 50, and now your denominator is going to be 1,000. Okay, so that's why in some ways it's just a number, but it certainly is a number that gives you a good idea of the relative importance of these journals. And the ones you see here are all journals that you're familiar with. If most of you are life scientists, you're ticking down the list going up, New England Journal of Medicine, Annual Reviews in Immunology. I'm not an immunologist. I don't care what the impact factor is. Oh, of course, if you're a neuroscientist, I mean, even if you had a friend on the editorial board of Annual Reviews in Immunology, and they said, hey, you're my friend, I'm going to let you publish a review article in Annual Reviews in Immunology, and you can publish it on neuroscience. Well, that's going to seem odd to everybody. It's unlikely that it's going to be cited very much. Yes, it's in a high prestige journal, but it's in the wrong place. So that needs to be taken into account as well. It's very much, there are general guidelines, but publishing is still very much an individual choice. That's kind of what I'm trying to say. So alluding again to the fact that, and this is something that actually Lene asked me to emphasize a bit, and I'm not terribly familiar with the Science magazine journal rank, the SJR, but here impact is more than just that number of citations divided by the number of publications in the issue. A number of other factors play in, and I'm not going to show you all the individual graphs, but just to go across, these are the.
Me dijo, ay, no importa, hay que se lo quede.
You'll see this journal again is at the top, just as it was for impact factor determined by arithmetic, let's say. And there are other factors that go into it. The other factors that go into it, in a way, the idea behind this ranking is what is the quality of the citation that you got. So if your paper is cited, let's say it's cited 100 times. And let's say it's cited 100 times because you invented a methodology that everybody uses. And it's easier for them just to cite your paper than to describe the methodology in detail. So your citations are going to be important, but they're going to be spread over a number of different kinds of journals. Whereas if your 100 citations are all found in articles that are published in either, again, I'm speaking as a neuroscientist, in Science, Nature, or Neuron, or let's say Cell, Science, and Nature, or whatever top journals you want to emphasize, that has intrinsically more prestige. People are citing that article more likely because it changed the field in some way. And so that's worthwhile bearing in mind as well, not only as a decision about what you read, but as a decision about what you cite, and as a decision about what you're again, where you'll publish, and how you view the information that you're taking in. There has actually been talk among publishers and editorial boards get together. A proposal was floated at a meeting I was at some time ago, which was, well, what if journals had a list of what authors are allowed to cite? Like, let's suppose that if you wanted to publish in Science, you couldn't cite any journals except this list of journals that science decided that you could well, that's not a popular idea. Nobody wants the journal to be a policeman who's telling you what information you can take in, who's to judge whether information is valuable. That should be up to the author. At the same time, it means that we miss an opportunity for quality control, for better or for worse. And these are decisions that don't have easy answers. I mean, there's a reason why in most countries there's multiple political parties, because people that are well-meaning think that there are different answers to big problems. Okay, so that's, as scientists, of course, we're expected to experiment. And we actually have been experimenting with publication quite a bit over the years. So just to finish up about the SJR ranking, it includes the journals and the country scientific indicators that are developed from information contained in the Scopus database. And it's a prestige metric that's based on the idea that all citations are not created equal. But as I think I've hinted to you, there's a certain snobbery built into the that notion. Whenever there's a system, there has to be an author to the system. And I would say whenever you look at ways of evaluating work, especially your work, you really should ask yourself, who's saying this? Who are the people that are promulgating these rules or these suggestions? And it's worth your while, I think, as a member of the community of science to try to pierce the veil and ask who's really coming up with not just the recommendations, but the meta programs that determine those recommendations. So I'm just going to go through a few slides here that are tips for publication in top-ranked journals. And I would never presume to offer tips for publication in top-ranked journals. I'm continually surprised. So I don't have all the answers. But I spoke with Kat Kellner at Science Magazine, and she was kind enough to provide, some guidelines just based on editorial experience. What she has seen works for people who publish in science. This is geared towards students, so I'm not talking down to anyone, I hope. But the idea is this is the kind of advice I would be comfortable giving my students. It makes sense. And it's good advice about doing science as well as publishing a prestigious scientific journal. Do the best possible science in your area, of course. At the NIH, we have a lot of postdoctoral trainees. That's our responsibility. We're supposed to train scientists, not academically. That's the job of this university and others all over the planet. We do not award degrees at the NIH, but it is our job to train people. And people come to the NIH for training with different attitudes. Everybody would like to finish their postdoctoral training with at least one publication in a prestigious area. It tells their colleagues back home, if you will. Some people stay, but many people return to their countries of origin. And you don't come back from the NIH with a diploma. So what do you have instead of a piece of paper that says you got a degree? Piece of paper that says that you published in Science or Nature or the Proceedings of the National Academy of Sciences. And people have different ambitions. You can see it. They speak very frankly about it. Some people come to the NIH and their mission is to get a publication in science. Other people, I think more sensible people, their ambition is to do the kind of work that could get published in science. That seems to me to be a healthier ambition. So do the best possible science in your area. Not as simple as it sounds. I had a mentor, Julie Axelrod, who won the Nobel Prize in Physiology and Medicine in 1970. And somebody put together a collection of his little pieces of advice over the years. He wasn't one to give advice, but occasionally some advice slipped out. And he said, be ahead of the curve, not too far ahead, which I think was a bit tongue in cheek, but what he was saying was, you should do work that people care about. You should try to solve problems that other people think are important problems. But be ahead of the curve, be creative, but not so far ahead of the curve that people aren't going to catch up with you for another 10 or 15 years. There's actually a word for publications. I think this may have been coined by Gareth Lang, but somebody came up with the word. Papers are called sleeping beauties when they don't get cited for 15 or 20 years, and suddenly the paper gets discovered because suddenly it's that people appreciate that it was ahead of its time, but that's kind of rare. Do the best possible science, be ahead of the curve, not too far ahead of the curve, be clear. It's interesting how obvious that is and how often it really does need to be said. Be clear. And my own experience about that is that for those who feel that not having English as a first language is a barrier to scientific communication in English, I sympathize, but I say at the same time, from my own experience, people that are writing in English as a second language often tend to be more clear than people who have English as a first language. Because people who have English as a first language think they're more clear than they really are. So clarity is very important, and clarity transcends the ability to babble on musically in a language. It's not about that. It's about the structure of your thinking, the structure of your sentences. Make sure that scientists you respect share your regards for your own findings. Of course, you think what you do is the best thing since sliced bread, but it's helpful when other people can share your enthusiasm, because they will often share your enthusiasm in ways that perhaps surprise you. It's often the case, I think we've all had the experience, that people will appreciate some aspect of the work we do for different reasons than we do. So it's always good to get a reality check, because you don't want to have delusions of grandeur. But getting a reality check can actually be a confidence booster. People can tell you things about the importance of your work that you actually didn't know. And finally, publish your results regularly and quickly. Working for science, Katrina said, whether science is your first and last, or your first stop, or your last stop, or your only stop, no matter what, publish your results regularly. And that's why it's complicated. You say you should publish in the best journals. Those of you who are academic, you know that the students you train have a rhythm. The rhythm is that they need to get their degree and publish their work and move on. And at the NIH, we have the same. It's a little more muted, I would say. We don't have that feeling of the academic calendar, but you all know what that's like. There comes a time there's a gestational period, and then you have to have the baby, and you don't get to choose to wait another 3 months because you want to have it in a different hospital. You have the baby. So there's an urgency to publication that shouldn't be denied. If you're not publishing regularly, you got to do a reality check, and that's of course true for all of us. And then continuing on, train in a great lab. Again, these are obvious things, but sometimes not so obvious. What makes a great lab? That depends on who you are. for you, a great lab might be one in which you hardly ever see your lab director, but you're surrounded by peers who are smart and ambitious and helpful, and that's awesome. You might be the sort of person who wants to have a good deal of face time with your mentor supervisor, in which case I remember being amazed about a laboratory at Caltech, Leroy Hood's lab. Leroy Hood was one of the inventors of the amino acid sequencer and later DNA sequencing machines. And his laboratory was so big that they actually had a baseball league, not a team. They had a league. There were some 70 or 80 people in the lab. And I'm sure some of you would think, no way, I would just get lost. I know I would get lost. I personally know I would get lost. But for some people, that is the environment that really gets them going. So we're getting off the topic of publication a little bit. Work on what you want to publish, but publish what you work on. This gets back to the idea is if your goal is just a cynical desire to, advance your career by publishing the best journals you can, the fact of the matter is sooner or later you're going to run out of gas. You have to work on what you want to publish, but you also need to publish what you work on. And of course, that involves endless negotiations about how long can you wait before you accumulate the story that you want to tell. I recently read a paper I'm pretty sure it was in Nature Neuroscience. It was a fascinating paper about a neuropeptide I'm quite interested in called neurotensin. What struck me about this paper is it was just published this year. It was first submitted in 2018. So much for euthanasia of papers that are, obviously they got enough encouragement to keep going, but not enough encouragement to be told your paper is accepted. So you can ask yourself, what kind of a compliment is this? Great work, but not yet for 4 years. This was one of Kay Tai's publications, and it was a very interesting one. It's well worth reading, but I really so I was quite surprised that the gestation period for that paper was 4 years. So no one works in a vacuum, so you should share your ideas with trusted and eminent colleagues at early stages of the work. I'll probably use the word again over the next few minutes. It turns out that trust is an important part of science publishing. We all really do need to trust each other as scientists. And there is, of course, a human desire. We said earlier, share your results with your colleagues. And, make sure that you're not deluding yourself. There's also a strong desire to say, I'm so sure I'm right. I'm not going to share this with anybody. They'll steal my ideas. They're so good. And I think, and Sidney Brenner, who won the Nobel Prize for very important work in determining the nature of messenger RNA, he once said, if I had people were asking him for advice, and he just said, if I had a great idea, I'd do it myself. Okay, so there's people are generous, but there's a limit to generosity. Okay, you can't expect people to give you ideas, but you can trust them to share your ideas and help you develop them. Again, during the course of deciding where you're going to publish. So I'm just making this point here because I think it's worthwhile to remember that you have it in your power to decide where you're going to publish your work determines the timetable of your work. And it's absolutely fine to make deliberate decisions and say, if I'm lucky, this is the direction I'm going to go in. And if I'm fortunate with my experiments, I'm going to do something really important. And if I do, I'm not going to get distracted. I'm just going to publish it when it's really, really, really done, really great. That's a path that everyone can take. And it's worthwhile to think about it. No matter what you end up doing, it's worthwhile, in my view, to think about it, again, within this context at every level of a student doing their thesis work, of a supervisor trying to decide what that student best needs to advance their career, and also at the level of editors have to make exactly the same decision, and peer reviewers. This paper has flaws, but do we need to start talking about this work? Is this work interesting enough that, flaws and all, let's start sharing? Okay, and that's a real conundrum in science. And people have come up with some very, I would say, very ingenious solutions to that particular conundrum. And again, this is the quote from Julie and from Sydney Brenner. So, and I already made the point about non-English speakers, but I think it's worth emphasizing. And I must say that as an editor and as a peer reviewer, I really feel that I have seen excellent examples of very, not very poor, but not very polished English writing, but the logic shines through that. And I've seen examples of papers written in excellent colloquial English, where the logic is shoddy and careless, and you can see right through that. So it's really not difficult to be clear. I think that really transcends rhetoric, I would say. And again, the current language of science is English. It was interesting to me to find out that we came, I think, fairly close in the 20th century to having German be the scientific language. But there was massive immigration of excellent scientists from Germany, and that didn't happen. But English is, you know, it was French, it was Latin, now it's English. It could be any language. We should be prepared for that and try to make sure that the thinking and the structure of the thinking in a paper is not rhetorical, but truly logical and scientific. Again, make sure that scientists you respect share your regard for the findings. This raises an important point about peer review. Really, this whole exercise today comes down to peer review. And if there's any message to, if I could give any message to students, it would be respect yourself as a peer reviewer and know that you are contributing intellectual capital to science as a peer reviewer. And articulating the importance of the work to your peers is, by the way, coincidentally, the basis for a good cover letter. Keep it short and keep it to the point, and have it be the sort of thing that you might want to tell essentially somebody who doesn't have much time to listen to you why it's worthwhile to read a little further into the paper. So, but you do finish with a publication. Science, Nature, and Cell published less than 1,000 of every 10,000 manuscripts received. We can ask ourselves, is that 10% of the best papers, or is it the best 10% of papers? Well, it's 10% of the best. At a certain level, randomness ensues. I'm sure that this has been the case for scientists in this country. It certainly has been true in the US. When money is tight, grants are hard to get. And at a certain level, you reach a point where you are really randomly awarding grants, because you've already hit the top 10%. And you really can't tell the difference between 9% and 8% from the top. And so after a while, it becomes a random process, and that has to be taken into account. And then you say, well, maybe instead of giving, 1,000 people $1 million, let's give 2,000 people $500,000, something like that. Now in science publishing, you could say the same thing. What is to stop the top magazines from just doubling, tripling, or quadrupling the number of pages they have? Pages don't cost money anymore. That's really something to think about. I don't have an answer for that, by the way. I know that a lot of electronic journals now are not really paying attention to how much space you take up. In fact, they don't even number the pages. It's the volume, and then there's a little E, and then there's a number. Your article has a number. It doesn't have a number of pages. Pages are old-fashioned. And yet, there are other bottlenecks. There's only so many papers that can be adequately reviewed. And so these are challenges that are built into the system, into the publication system. When you, again, I'm just going to quickly make this point, and that is readership versus the target audience for the key message. Who do you really want to see and to cite your work? So there may be times when you want to target to a journal because you know who reads it, and you know who will appreciate your particular input. This next series of slides I'm going to go through kind of quickly. What this stems from is a trip that I took to Saudi a few years ago. I happened to be on the editorial board of Science Signaling at the time, and an editor came from Nature magazine, and together we kind of discussed with the director, the students, the principal investigators at King Saud University, what's the deal with publishing in Nature and Science? What are some of the keys? And Brian helped me out by giving me this thumbnail sketch of be familiar with science, but it illustrates some general principles. So the American Association for the Advancement of Science was founded in 1848 in Philadelphia. Science, the magazine, was founded by Thomas Edison, the inventor, one of the inventors of the light bulb, and it became the official journal of the American Association for the Advancement of Science. I mention this just because AAAS is a not-for-profit organization. Nature Publishing Group is not a not-for-profit organization, but it's really not fair to cast Nature as the, if you were putting it in political terms and you were American, you'd say, well, science is kind of the Democrats and Nature is kind of the Republicans, right? They have different views of free market and profit and so, but that's probably not really true. At the level of the editorial boards, they're actually very, very similar. But what I wanted to get to is just this kind of workflow. So they're looking at a couple hundred papers a week. 90% of those are rejected, 10% of those are accepted. So the idea is to be fair to the people that are submitting. If you only have a 10% chance, give me the bad news right away. Don't take 2 months to give me bad news. So there's a little bit of playing the odds. It's also a weekly journal, so it's about topicality. They've got to put the best stuff that kind of happened that week. Now, if it's a mission to outer space and they come back with all these pictures of Mars, well, they publish them this week. That's like news. So Nature and Science have a certain news quality to them. Other work is not really newsy, but it's still, it has to do with moving fields forward. Fields should move forward rapidly, so you want to publish fairly quickly, and that's why they have this 2-tiered review process. submitted manuscripts go to a board of reviewing editors and to the science editorial staff. They're selected for further in-depth review. And finally, they run the gauntlet of the reviewers. And in the end, I mentioned this happens to be a paper, again, it happened long enough ago that I don't consider this self-aggrandizing, but this is an example of a paper that we sent to Science magazine and it came back summarily rejected in no time at all, what we call a desk rejection, in less than a week. And it just didn't feel right. We felt like maybe they just missed the boat. And Betsy Murray had a colleague who happened to be the chair of her equivalent of departments in our place, her section, her laboratory, Mort Mishkin. He said, yeah, I kind of think they missed the boat. So he made a polite telephone call and said, could you just look at this a little more carefully? And eventually it was published. But again, it was something that was timely. It just so happened there was a controversy in the AIDS field about whether neuroAIDS was caused by macrophages invading the brain or whether those macrophages broadcast signals long range to cause cognitive changes. And people cared about it. There were no experiments that could be done in humans to solve those problems. And this paper contributed to answering that question. So when you really believe in your work, get some reinforcements, because editors don't like to make mistakes. You know, these are hard decisions they're making. There's a saying about editors and editors of journals and deans of universities. Goes something like an editor says no when he means maybe, and he says maybe when he means yes. And a dean says yes when he means maybe, and he says maybe when he means no, because the editor doesn't want to give false hopes and the dean doesn't want to make anybody angry. So that's just the style. So anyway, turning to another journal, the Journal of Biological Chemistry. This is a journal this is a journal that could almost, oh, we had a question. This is a journal that could almost be said to follow the maxim that it will publish anything that's submitted to it. That's not true, but the general style of the journal is it has an editorial board of about 600 scientists. All the reviewing it's rarely done outside of the board. The board meets every year and gets briefed on things like, what are our standards now? Are we going to let anybody use an antibody that hasn't checked and knock out mouse with that antigen, et cetera, et cetera? Are we going to let people do knockdown experiments without showing that the actual level of protein was decreased? So the board is well schooled in current standards of the field. And so the journal is rigorous because the rejection rate is relatively low, but people give up. Okay, that the idea is, you know, sure, you can publish here, but you know, you got to take your paper and you got to do this experiment and this experiment and this experiment. And some people say, I'll publish in another journal. I'm not going to be that rigorous. So that's a little bit different style. It's true that a lot are returned that never get peer review. But again, it's not the same level as science. The overall philosophy is we will take what we get and improve it. And then there's publishing in Nature, and it has its own style. There's certain basics that every journal is going to have to adapt, even if they have their own styles. But and sometimes journals have a kind of mission where they pay lip service to a certain philosophy that they may or may not actually carry forward. But in general, Nature and Science, as I said, are more similar than they are different. I would say one difference is that in Nature magazine sometimes allows its, and this is just the Nature policies policies, all authors are responsible for the paper, community standards for depositing data, copyright and author. Really, this is just boilerplate for all journals. All journals would like you to think that they follow these policies. Some journals follow them in the breach. That is, they make enough exceptions that they're not really following those rules. I went through a stint of reviewing when, just to be kind of stubborn and obnoxious, every paper I reviewed that had Western blots, I don't know if you're all familiar with Western blotting, but the point is that you show a representative piece of data, and then you show the graphs that you got when you repeated that experiment again and again and again, at least 3 times. And so I realized we were in an era where if somebody has data, they have to have photographed it. They can show you the primary data instantly. So I took to just asking, may I please see all your primary data? It won't appear in the manuscript. And I was really surprised at how often people were embarrassed by not having the data they claimed to have. It was a bit shocking. And this, again, the issue of trust. Where are you going to put your level of trust? And I think students can be happy that, well, I think we're getting better and better at this. We're getting better and better. It used to be the attitude was, you know, science is self-correcting. If you publish something that isn't true, you'll just be punished for it because people won't be able to reproduce it. You'll just cover yourself with shame. That's not as true as one would wish it to be. And so it's probably a very good thing that we're getting much more transparent about following these policies outlined. A very quick word about spin-off journals. So this is a game played in the publishing biz, I would say, that Nature, Cell, any major journal that's having a lot of success, that's getting more good papers than they can publish. What do? They have little sibling daughter journals, progeny journals that catch the overflow. If we, the scientific community, are pouring, 100 articles into Science and they can only publish, 5% of them. Well, what about the other 5%? Let's hold on to those. Let's not waste those on our rivals at Nature. Let's have a journal called, in the case of Nature Neuroscience, Nature Structural Biology, Nature Immunology, it goes on. And Science has Science Translational Medicine and Science Signaling. Now, the only point I want to make about these spin-off journals is the spin-off journals are often online. They don't have a print version. Practically nothing has a print version anymore. I actually visited, Yime and I were having a conversation about a journal that we were contributing a special issue of the journal. And we thought, for the authors, wouldn't it be nice if we actually printed this and bound it? We could probably do it more cheaply than the journal can publish itself, because they don't do hard copy anymore. So I went to our library to see what the journal actually looked like. And I was so shocked. Our library, the NIH library, is now the size of this room. It's a bunch of those kind of shelves that when you press a button, they open up, so you can have compact space. The only journals we have, apparently, are ones that discontinued before they all went online. So they don't have, if you want a copy of it, you actually make a photocopy. Anyway, the point is that the spin-off journals are very much online journals, and they offer various things to the scientific community. So Science decided, well, let's have something called Science Signaling, where we will really help create a virtual community. You can be an immunologist, you can be a neuroscientist, you can be somebody who's interested in metabolic disease, but there are people in all those different fields that care about how transcription is altered when cyclic AMP levels go up in cells, or when MAP kinases activate various cellular components. So let's have a journal that speaks to signaling people. And these are just the features of that. And in the interest of time, I'm going to just sort of zoom through this. The point is that science signaling did two interesting things. One, they had something called an online signaling environment that all publications could contribute to, that would be curated by the editorial staff. And they also occasionally had articles in science magazines. So this was a way of handing out little candies to people that made an article in science signaling. Publish it, science signaling, and we'll mention you in Science magazine. So there's this kind of resonance that builds up. And the knowledge environment, by the way, is kaput now, but science signaling is still doing very well. It's a high impact journal. This is a journal that's become high impact by simply hardly publishing it. There's 2 or 3 articles per issue. So if you're lucky enough to be one of those articles and you get cited a few times, you're doing your best, you're keeping up with the impact factor. That's many different styles and pathways, and convergence of self-interest and scientific interest. One of the things I want to mention is the reviewing flow chart, because this gets to the idea of what you, in my view, what all of us as peer reviewers should expect of the journals we peer review for. This is my personal fantasy, but I'll share it with you. The manuscript is submitted to the journal. The editor assigns reviewers. It goes out for review, and 2 or more reviews are returned to the editor and shared with the authors, and also with the other reviewers. Then the authors end with an editorial decision: reject, accept with minor revisions, major revisions, or no revisions if you're very lucky. Then the authors look at that and they say, you know, I'm going to do these things. These are reasonable. This is going to improve my paper. I can do it. We can do these experiments. Let's do them. And you return the manuscript as the author, and the reviewers look at it again and they say, yep, they did what we wanted to do. That's fine. And now it's up to the editor to say, I've got one reviewer who's still saying this paper cannot possibly be published unless they breed 4 more lines of mice and do experiments that surely will take another year. And the editor says, now I got to make a decision. If I wait, if I tell them that, they may go to another journal and we'll lose this pretty good paper. Plus, I like the information here. I think people deserve to know it. So the editor has to make a choice. And then finally, there's an editor's decision. Now, this is where journals are kind of going in different directions, testing the waters. Journals have decided, we scientists have somehow decided that everybody should read reviews. That reviews shouldn't be secret anymore. Secret, anonymous is bad. Now, so you publish the reviews along with the paper when it finally comes out, so people can know. Now, do you publish the name of the reviewer? Is that a good thing, or is that a corrupting thing? It's something worth thinking about. And do you even publish the reviews? Because in some ways, who cares? You're going to read the paper or not read the paper. Is it really true that the reviewers are going to have some amazing insights that the authors didn't bother to put in the paper? Well, then they should have told the authors that. The authors should have changed the paper accordingly. But sometimes there are controversies that come up, and it is worthwhile opening up the review process to the public so they can know more about it. I wanted to say a few words about the special issue, but I think I don't want to overstay my welcome here, Ricardo. Should I be thinking about wrapping it up in a couple minutes? Yeah, okay. So thank you for your attention, and this is the home stretch now, 5 more minutes or so. Okay, the special issue, we're going to skip that for now, but it's an interesting example of adding editorial value, but it's so old-fashioned. So you guys are familiar with special issues. A journal says, oh, there was a in our field, there was a conference on neuroendocrinology of the gastrointestinal tract. So let's have a special issue and ask people to contribute in that field. That's very nice for the reader, because the reader can then go just to that special issue and see a lot of related articles. But what special issue? I just told you that I went to the library. They don't have copies of these things anymore. So if everybody's getting their info from PubMed and from Google, then the special issue has no real coherence or meaning. So how do you make it meaningful? There are ways to do that. You reach out into social media. You say, hey, we had this awesome meeting. All kinds of interesting things. Wish you were there. You should see the special issue. You'll be very impressed. So people will go and try to find that special issue. Do journals make it easy for you to download a special issue of a journal? They do not. It's an opportunity that they're missing. If you do contribute to a special issue, it's worth your while to ask, is the editor really adding value to your work? Or is the editor exploiting your work to get more content for the journal? It's really worth asking. And a tip-off is, if they have a special issue for no other reason than they're having a special issue, you're probably getting ripped off. If they're having a special issue because they actually had a meeting, people talked, learned from each other, and there are some new insights to be had, that might have some value. That's just my opinion. And the difference between the last century and this one is that we're in the age of PubMed and open access. And that has, of course, huge implications for scientific publishing. Even if we were still publishing on paper and in journals, PubMed and open access would still have important implications. It levels things out. You're going from a vertical organization of scientific information to a more horizontal one, where, you know, I hate to, I'm really showing my age here, okay? I thought the NIH really moved into the modern age when we had this app called Bookshelf. And here's how, yeah, see, you're laughing. You're literally laughing out loud. I am too. So the app was, you go online, you see icons of all the major journals. And you double click on the journal and you can page through it. Who would do that anymore? But, you know, that's just welcome to modern times. So PubMed and Google have really, really changed things. We talked about Simago and the difference between impact factors and journal ratings. So I want to close just by saying what can we do and what should we do? And I think this is a question that's really directed to all of us. Whether you're a medical student, a graduate student, this is your future. And you can make it now. If you're in a department, how are you going to help your colleagues, encourage them to get the most out of their publication? If you're a department chair or a dean, how are you going to evaluate the productivity of the scientists that you're supposed to be helping to optimize and actualize? So I think these are really important questions for all of us. Will good science find its way into the scientific literature all on its own in a free market of ideas? That's kind of what we all kind of think when we don't want to have to think about publishing. You know, it'll get taken care of. It'll come out in the wash again. I'm going to bear down on my stuff and let the world take care of itself. Or should we be insisting on journal transparency of process and accountability through the review and scientific publication process? I want to make the strong argument that we should own peer review. That this is I review about 50 papers a year. I spend about 5 hours on each paper. So I'm putting a big chunk of my time. And I'm starting to think that I've been taking myself for granted. And so all of you, I feel like we should all think that way. If you're doing peer review, you're doing service to the scientific community. You're not asking for anything back, but at least your review should truly count for something and not just be a way that a journal can say, oh, yes, we have peer review, and just keep turning the crank. So I would say we should all, when we get an invitation to review papers, look very carefully at who we're reviewing for. Of course, you want to be interested in the paper. You know, if, oh, that's in my field, I want to keep up with my competitors. But also, I think even if the paper is not exactly in your field and you're really reviewing it as a public service, it's important to remember how precious your time is and how you could be reviewing a more deserving paper for a more deserving journal. And as they say in the frontier, keep your powder dry and wait until there's a paper that's really worth reviewing for a journal that's really worth reviewing for. I don't have time to tell you a little story about the Science Citation Network analysis. It's kind of fascinating. It has to do with how journal articles get cited by people that agree and people that disagree, how there's a kind of a bias against disagreement. And I mention it because this is an area that people are really trying to make reforms in. There was a scientist named David Dewey, I'm not speaking ill of the dead here, but he was a pioneer in neuroendocrinology. He coined the term neuropeptide, an area that I work in. I think it's very fascinating. But he had the hypothesis that vasopressin is released from the pituitary gland, goes into the bloodstream and feeds back to the brain to affect memory and learning. That turned out not to be the case. However, Professor Zhang's group has done important work in this area. Turns out that vasopressin is important in mental processes because it's actually released at synapses in the brain. So Dewey gets a lot of credit for pushing a field forward just by getting people interested in neuropeptides, even though some of his ideas were wrong. And Gareth Lang and his son actually did a Science Citation Network analysis of this process. At this point, I'm just going to say I highly recommend you read the paper. If you want a copy of it, I'll be happy to send it to you. So is science self-correcting? You know, probably not. That was certainly Gareth's conclusion about the Dewey papers. There were people that were still, like zombies, were still quoting some of the key papers, but they weren't quoting them because of their content. They were quoting them to kind of show respect. Oh, I know that David Dewey coined the term neuropeptide, so why don't I cite one of his papers? Okay, so that sort of thing happens. I would urge everybody at this point, pick a team. Do you favor anonymous or non-anonymous review? Think about it and vote, because you're about to get a chance to vote with your feet over the next 5 years, I would say. Pick a team, society journals or commercial journals. You can decide how you're going to budget your effort to supporting journals through your peer review and through your contributions. So it's a two-way stream. Of course, the more prestigious journal will enhance your prestige and will let your work be known to more people. But if you publish in a journal and publish your best things there and review for that journal and give the most rigorous review you can add value to the journal at the same time that that journal is adding value to your career, I would say. So we already talked about primary data, and try and as peer reviewers, I think we should all really try to just, it's this trust question again. You want to trust people, but it's always okay today to ask people for anything you want to see. That is totally okay. Anytime somebody shows a representative anything, you can say as a reviewer, I want to see 3 more examples of the so-called representative micrograph. Is this really representative, or is it the only thing you could scrape up after 19 months of work? You deserve to know. You can ask that question. You feel free to ask for whatever you want because everything's electronic. The authors are not making any effort to comply with your wishes. It's easy for them to do if they've actually done the work. It's impossible for them to do if they haven't done the work. So it's worthwhile to ask the question, in my opinion. I want to actually close on the thought that peer review is the intellectual infrastructure of the scientific enterprise. The publications you see are supported by the peer review that you don't see. It's very important to know how that happens and to make sure that it really does have integrity. So I'm all for expanding respect for the peer review process. I'm all for teaching students to do peer review early in their career, to decide how much time they're going to spend reviewing a paper, how deeply they're going to go into that review. Are they going to read all the papers and the references to make sure that the referencing was done correctly? What level of effort are you going to put into the review? And if you can't put in an honest level of effort, don't do the review, because you're probably not doing anyone any favors. And I think that it's my view, and I'm not going to endorse any ones, that prioritizing society-based journals based on institutional costs and collegial support is very important. People at academic institutions should be talking to each other about the kind of journals that they are buying into and whether they can add collective effort to those journals. And I told you that science is a society journal, Nature is not. I think those two are exceptions. Nature really carries itself like a society journal. I almost like to think of it maybe too romantically as it's kind of the journal of the Royal Society of London. It's got such a tradition of history that we should think of it as a society journal. But journals that are simply there to just churn out publications, I think are probably abusing the system, and we should maybe not give them so many chances. And finally, this just in, Mario Zetter caught it in his email, and later, earlier today, I think about 3 hours ago, it came in my email. eLife has started a scientific publishing enterprise called Peer Review Without Gatekeeping. I really recommend everybody to read this article and think about it. Their basic shtick, their basic thing is that they're not going to reject papers anymore. They're just going to review the papers. And then the authors can decide whether they're going to change them or not. And then after that review process, the paper is going to become a what's called a preprint, I believe. And then if the authors choose to do it, they can make it a VOR. So it's, what is that, volume on record? They can make it permanent. Once they make it permanent, PubMed can then pick it up and everybody can, so these things that go into bioarchives will post your article. You don't need to have it reviewed. You can write whatever you want. It has to be kind of reasonable. They have an editorial staff that says, this is a joke article, we're not going to post it. But if you belong to a scientific institution, your colleagues belong to a scientific institution, it looks reasonable. Bioarchives or Med Archives is another one, will post it. But posted is not going to be taken by PubMed. So you're not going to be able to easily search for that. It's only once there's a version on record. That's what it is, right? Version on record. That means you can't change it anymore. Okay, if it's posted, you can keep changing it. But so what eLife plans to do is they plan to accept all the articles that come in. Some will be reviewed, and the ones that are reviewed will be accepted and can become VOR. So now the question you want to ask yourself is, this sounds great. And their editorial announcing this is so heartfelt. There's no question these are sincere scientists like all of us who really want to make science better through a new publishing model. but it's worthwhile asking, is their model really new? Because we all have to vote with our feet or vote with where we send our manuscripts. And so it's up to all of us, I think, from students to chancellors of universities to start really getting involved in creating this new reality of publishing. And I'm sorry to just go on for such a long time. You've been so patient. I very much appreciate it.
Thank you, Dr. Aiden, for this lecture. If someone in the audience have a question, please. No, no. Dr. Lee?
I would like you to all comment the difference of the society-based journal and the commercially based journal in terms of the payment that the author pay the publication, or the most of the society-based journal we do not pay the publication, and also the society-based journal many times invest in scientific activities and society back. And we wish that you can
So typically society journals are organized by scientific societies, and then they find a publisher, or a publisher finds them. And the publisher agrees to handle the publication process, which costs money. And the way that the publisher recoups their money is by selling subscriptions of the journal to libraries and other interested parties. I say not only libraries, because sometimes even private research institutions will have quite extensive libraries. They're willing to invest in those, so their scientists can sit in the reading room and read what they want. Again, so much of this model is from the 20th century, but it's still, it's almost as if the society way of paying the costs is like in a glide path. There's really no future for that. And then the other model is that the person submitting pays the cost of that are associated with publication. Some journals charge more, some journals charge less. There is, and here there's a role for cynicism. That is, you can think of journals quite cynically that charge money to the person submitting the article to cover the cost of open access as pay to play. You got enough money? Great, you can publish in our journal. It's almost like vanity back in the day when, when anyone who owned a castle could publish a book because they just went out and had it printed and self-published. So that's really, in a way, we're self-publishing. But at the same time, we're having a discussion about this morning about this journal is charging $2,000 to take your paper from a submission to something that is a VOR, okay, a final version that will be published in eLife, the journal. And from where I stand, eLife has a pretty good reputation as a journal. We publish there, and I see good stuff there. So I think it's a fine journal. But you pay $2,000 for that. Now the question is, who's going to pay that $2,000? Is it going to be my institution, the NIH, or is it going to be your institution, the National Autonomous University of Mexico? Who's going to pay? And we don't know that yet about this. They're taking a gamble. They may just not get enough business to keep them afloat. Frontiers in everything, right? Frontiers, yeah. Their charge is what, about $3,000, something like that. And most institutions will pay those pay charges. The difference is that when you finish in Frontiers, it's automatically a BOR. Whereas with this, it's kind of a voluntary, you don't have to pull the trigger, but those are the dollars involved in US dollars, so. So $2,000. 40,000.
Another question I ask.
Sure.
Yeah, and another thing is that I observed that these very famous journals now hire very young scientists, just finished postdoc, to be their editors. You know, they take decisions, they make the first very quick review, and they decide to go forward with the peer review or reject that. What is the advantage? Why they are doing that? Especially in Nature. In Nature, they use very young, immediately out of finishing postdoc to be their reviewers. Do you,
Those young people have the energy to travel a lot. You've heard the expression, will Muhammad come to the mountain or will the mountain come to Muhammad? When John Maddox was the editor of Nature magazine, John Maddox didn't have to go to meetings. The meetings came to John Maddox. People would tell him what's important. He was in touch with all of the top echelon of science. I believe these young editors are going to one meeting after the next. They have their ear on the ground and they're trying to figure out what's the buzz, what's happening, what's the really interesting thing that's going on. Oh, stem cells. Yeah, that field is kind of like going down a little bit. What's hot? What's popping? There's almost a kind of a like you'd find on Fleet Street, you know, a kind of economic. I would say that the biggest word in that style of publishing is FOMO. You know, fear of missing out. Let's not miss out on something. Nature doesn't want to miss out on what science is going to get. Science doesn't want to miss out on what nature is going to get. And that's why I believe they feel that that younger people are better at sussing out what's happening.
What is the fashion?
I would perhaps, yeah. There was we actually had a visitor from Nature magazine who came to the NIH and gave a very well-attended lecture, essentially about how to publish in Nature. So imagine going to one of the largest research institutions in the country and saying, here's how it works. Here's how you can adapt your research to our publication standards. So again, it's a new way of thinking. And I believe it takes younger people to be adaptable and flexible and like to think that. Yeah.
It's nice to see you again, Lee. So how I perceive technology is a gatekeeper. So last week I published. It was artist's task. I spent maybe 4 months. I got to reject technology of sound. I didn't use optogenetics, I didn't use immunogenetics. So because and they will demand experiments to be done. And I simply couldn't do it. Not because I don't have time, because I don't have money. So I fear for the future. I fear for the future in Latin America that are where these technologies are not. So do you believe that high-tech journals have value more than the
Yes. I was at a Society for Neuroscience lecture that was given by a very eminent neuroscientist, Trevor Robbins. And he showed a slide of one of his 1993 papers. Tongue in cheek, he said, oh, it's 2015, time for somebody to republish this with optogenetics in Nature. So I think optogenetics is wonderful. And we're learning a lot from it. But technology gaps are really a problem for mining creativity on a planetary basis. I think most of us believe, I certainly believe, that talent is more or less uniformly distributed across the planet, that scientific talent doesn't reside in particular countries or in particular groups or in particular demographics. And so recruiting good scientists can become difficult. But I do think there are some steps that are mitigating. One, I know we have a recruitment program for scientists at the NIH called the Statman program. And I was on a recruiting committee, and we were specifically instructed not to give too much attention to one name journal publications on resumes, because those people were publishing in Nature and in Science in a small group of elite laboratories that could publish in Nature and Science because they could collaborate with other people that had technological wherewithal, again, exactly as you say, to overcome those obstacles. The loss, I think, is going to come at all levels. It's going to come at the level of, it's just a loss in human resources. I don't know what is to be done, but I agree with you that it's a problem.
We have two questions from our session, Zoom and from YouTube. If you're okay with it, to answer them. Doctora María del Carmen Cárdenas, professor at our Department of Physiology, sent the next question. What do you think about MDPI journals? And what is your opinion about predatory journals?
My opinion about predatory journals, I don't know what the acronym MDPI stands for. I'm so sorry.
DPI, it's an editorial. Well, it was considered by journal Jason.
It's a publisher of open access.
Okay.
Yeah. It was considered by the SGR a few months ago as a predatory journal.
Yeah. Well, I think that predatory journals should be named and called out. I actually supported the idea of a kind of a, policing network that would say this journal, in my opinion, at minimum, a journal ought to keep its archives available to inspectors. And those inspectors could be any of us, except that, the names are named, so there's confidential records. But if you go to a journal, I actually had a slide up here showing a paper that was submitted to a journal on October 1st, and it was accepted by that journal on October 7th. This, to me, is a clear indication that somebody said, I will trade the merit of my work for a speedy acceptance. It's just, I don't think it's possible to properly review a paper in 7 working days. That means the editor has to get it, has to choose reviewers, send it to the reviewers. Everybody's a busy person, and they have to write a review, which for me, like I said, takes 4 or 5 hours, and get it back and get it accepted, which means that it has to have 2 rounds of review, even if unless both reviewers said accept without modification. To make this answer is getting too long, I'm sorry. I believe that journals should be made to be transparent and show what their review process is. And if they can't do it, if they have irregularities, like they suppress negative reviews by saying, click this button if you endorse, and don't click any button if you don't endorse, just go away. That, to me, is a corrupt practice. And there are journals that do that practice. And I don't think those journals should continue to exist. clearly, to me, clearly not good for science. So,
Okay.
yeah.
Thank you. And the last
Thanks for the question.
What is your opinion? This is going to be a good one. What is your opinion on the use of Sci-Hub as a source to get articles? Sci-Hub.
Oh, I don't have an opinion on that.
Okay.
No, I'm sorry. Maybe somebody does.
First, I would like to express my gratitude for your excellent lecture. In your experience, what do you think about that Latin people have more troubles to publish than European people or American?
I think one way, first of all, I'm not expert enough to say what fraction of that is perception and what fraction of that is reality. Because what does trouble mean? But I'm sure that there are people that have opinions about it and that have facts that back up their point of view. And it wouldn't surprise me if it were the case that there is a systematic review bias across our whole planet. It could be like that. It seems very feasible. And I believe that one way to overcome those kind of biases, in fact, is society journals, because society journals tend to sponsor meetings. Meetings can tend to, in fact, require representation. I know, and I'm not beating a drum here, but I belong to an organization where we publish in our proceedings all the countries that people came from. And we feel to be proud of ourselves when we have more countries and more even distribution across countries. We makes us, I don't know why, it makes us feel like more powerful or stronger or more represented. I don't know, but everybody in the society seems to like the idea of being more inclusive. I think that the inclusivity also is very good for international collaborations that can then deal with the issue that was brought up earlier about technology gaps. So penalizing people who are very creative because they can't do a particular type of experiment, that's a loss to science in general. We should try to mitigate that if we can. But I think institutions can also do something about it. You know, when this idea came out from eLife, I just had the random thought, you know, what if every major university had its own journal? And it just said, okay, you guys are all professors. We have 100 spots, and you all compete for them. And we're going to lay the prestige of our institute on this journal. There is a journal of the National Cancer Institute, for example, and it's only as prestigious as the National Cancer Institute is. I think there's a variety of ideas out there, but this is really the time for people to be paying attention. Because this, for example, is this eLife thing. At what timing? It's so lucky that this came out today and that you flagged it, because I think this is such a perfect example of a group of creative, well-meaning scientists trying to come up with a new way of doing things that's more fair and better for everybody. But read the fine print. Read the fine print. Decide if you think this really is something that's intrinsically more fair to everybody, or if it's going to be one more thing that enhances the biases that you're finding are limiting you. It's worthwhile to explore.
The last question, please.
Thank you. I would also like to thank you for your lecture.
It was my pleasure.
And thinking about, like, for example, many of our things, like me, PhD students, and
talking about like the relevance of paper publishing, and taking into consideration that most of us are not publishing like experiments right now. But what do you think the relevance is right now, or will be in the next years of, for example, review articles? Are they relevant anymore, or?
I think they're highly relevant. And I really encourage students in my lab to contribute to review articles. And I must say, if there's one segment of scientific, you guys, you shouldn't be allowing me to just give my opinion. Please understand it's just one opinion, okay? If I get a little warm. But what I've noticed, an absolute trend of people who have no business writing review articles. I notice it in my field. I say, you know, this person has not published in this area. Why are they writing this review article? It's suddenly anybody can write a review article. So I really think it would be very good for mentors to say to students, I want you to help me write a review article, but you're a student. You have no business writing a review article. You've got to earn the right to do this by gathering all this literature and really, really focusing on it and understanding it. And I think if you get that opportunity, if your mentor gives you that invitation, I would advise you to accept it, because it's really fun to write a review article. It's a big headache. At a certain point, you have all these papers and this thing, it's like writing a term paper, something for school, you know, an exam, but it's worth it. And you realize life is short. You want to spend 10 times as much to be a real scholar, but you don't have 10 times as much time. So you have to be the best scholar you can be and still maintain your standards. It's a good exercise. So I highly recommend it. Thanks for letting me express that.
Dr. Aiden, thank you so much for this passionate lecture. And on behalf of the research coordination of the Department of Physiology, I give you this recognition for this lecture.
Thank you.
Thank you so much for your assistance. Para los que se encuentran en Zoom, les recordamos pasar, bueno, creo que ya se había pasado el link de asistencia. Y bueno, para las personas que se encuentran acá, que puedan firmar. Les recordamos que la asistencia a los seminarios departamentales pues es de 1 año, por lo que es subsecuente la asistencia que deben de tener. ¿Okay? Muchísimas gracias a todos y que pasen una excelente tarde.
Really nice. I'm glad you thought so. It was really appreciate the opportunity. Sometimes you don't really think through things deeply until you have a chance to address other people. Then you have to gather your thoughts.
Yeah, totally. Actually,